So another thing you could do, this is probably isn't the best example, but we have different colors of light filters as well. So if you were interested in their movement in different wavelengths of light, for instance, then you could do a little flap of color over top of each one. You can see here that's a little hard to see, so you need to figure out, we might want to put extra light on it or something. But you could do like a blue, red, and yellow, or a green, red, and yellow, or again, that's where you look at the literature. You have to have a reason for making those choices. It's not just like random choices. It's like, you have to think of why you might want to test those wavelengths. But yeah, you would just put like a little piece of color over there. And so each treatment has a different color. And then you do the same thing. Okay. So let me zoom back out. And we'll look at the crab for a second. Okay, so here's our crab. This is a little shore crab. Okay, so the crabs, they like to jump out of shallow containers. So if you're doing these guys, you wouldn't want to use a petri dish. You'd want to use more like a stacking dish. And I'll show you the different glassware in a moment as well. Right now I have it in a beaker just to keep it contained, but yeah, even a stacking dish they can get out of. Some of you found that out when you came here for the lab. I remember seeing one running across the floor. So the other thing with shore crabs is there's males and females. What I've found when we go to collect them, it's hard. Sometimes there's just like all males or all females. It's hard to get the exact amount of one or the other. So it's sort of usually better just to assume you're going to have a mix. And it is good though to keep track if you can, if you have time. So for each one that you test, it's good practice to just note if it's a male or a female. And that way, if you might notice some interesting trend that would then inform future experiments. So you might notice all the males don't move at all where the females do, or vice versa. But yeah, as I said, it's sort of hard to get all females are all males, so just expect to get a mix of them. Okay. What else? Let's see. Okay, and the crabs, as with the Tegriopus, you could do something with pH or with salinity, and we keep them in the same salinity and pH as we do with the Tegriopus, so 30 parts per thousand and pH 8.3. Okay, so you would assume that's sort of your control or standard, and then you would vary on either side of that. Again, you could do light as well with the crabs, just like I showed you with the Tegriopus with light filters. And we also actually have light filters that just give you different amounts of light. So you could look at color, or you could look at darkness versus light. So 100% light versus 50% versus 25, something like that. Okay. Another really interesting one to do with crabs that we've had a lot of people do is sediment type. So I'm going to show you in a second how we can arrange to have different types of sediment in a way that's measurable. Okay. The other thing I haven't mentioned here yet is temperature. So that's another option, is to vary the temperature and then see what their movement looks like in the different temperatures.
Robyn, what kind of reactions do crabs have? I've noticed in the literature they're measuring the antennae flicking, but what is something like easier to notice?
I think with the crabs you could do the same thing I just did for Tegriopus. You could do movement. They don't tend to move around as much as the Tegriopus though, so we have had that where students will sometimes just have a bunch of data points that are just a dot because it just sat there the whole time. Or they'll, but definitely movement is one. Crabs are also really good for choice experiments, right? So then it's just whether or not, then you're not measuring like a continuous variable, you're just saying whether it chose something or not. And I'm going to show you an example of a choice experiment. Actually, I have this right here, I can show you. There. I can just put him in here right now. Show you. There you go, Crabby. So here's an example right here. So this is light filters. There's a clear one, so that's letting in all the light, medium, and then dark that's obscuring most of the light. So there's a little bit getting through there still, but most of it's gone. So in this case, if you wanted to do a choice experiment, you would drop the crab in there and then give it a certain amount of time to make that choice. So it could be a minute or 30 seconds. You would have to kind of come up with something that's reasonable. We've often done 30 seconds or a minute because then you have enough time to get through enough trials and yeah, and it's just a good amount. Okay, and then you would just wait to the end of that minute and then see where it ends up. So right now it seems to be in the dark one. So if we are doing that for this one, I would just mark that down as it made the choice of this dark treatment. And then you would take this crab out and put another crab in. So that's the other thing. You're only going to test one individual at a time. So sometimes people think we'll just put all 10 crabs in there and see what happens. But then the statistics for that kind of experiment are a lot trickier. So to make it simple, we just say one at a time, and usually you just use the same test container. Then you know you've kind of standardized everything. So we would test this guy. Once he's done, take him out, put the next one in, do the same thing, and do that. Usually we like 15, I don't know what Maria said, but usually like 15 to 30 data points depending on time. Maria, you're muted.
We've said 15.
Perfect. Okay.
For this one,
so, yeah. Yeah, and so as you can see, that if it's a minute each, that's only about 20 minutes total testing, so which is a good amount of time. Yeah, he really likes that dark one. Maybe this is his preference.
It looks like it.
Yeah, he's there. So I guess, yeah, okay, so that's one example of a choice. There's other, show you this one too.
So I remember there was one group we had quite a long time ago. I don't think it was a feasible experiment, but what they wanted to do was we have these stuffed birds in the lab. One of them is an owl, and they wanted to like take the owl and put the owl over top of the dish and see what would cause them to take cover.
Yeah,
The owl would cause them to take cover.
I think they did end up trying it, but yeah, they didn't. Sometimes you try something and realize it's just, like Maria says, just not feasible. Because
yeah, it has to be testable. Yeah,
exactly. Yeah. So this is another one. This is actually a nice setup because they've made a little trap door for the crab to go in. So in this first one I showed you, you also have to think about where to put the crab when you start, because maybe I'm influencing his preference by putting him in one of these 3 spots. So you really want to put them right in the middle if you can, right? So in this case, they've made that little trap door so they can just plunk the crab down in there and then give it its time to make the choice. And I think they had a bit of space at the bottom. So yeah, so they have this little contraption. So it goes down and then it has some space to move around down here. Yeah, so again, that's another one with different colors. And you could do that too with different sediment types. So you could have a dish like this and make 3 different types of sediment and then put it in there and see where it ends up.
and we have different sizes of sediment, don't we? In the lab.
Yep, we sure do. Yeah.
And sieves.
Yeah, maybe I'll just show you that now since we're talking about it.
Okay.
So I just want to show you how this. So this is a sediment sieve. I'll show you a wide view in a sec. But what you can do with this is sieve out the sediment so you get certain standardized sizes. And that's kind of a good thing to do because then it ensures your experiment can be replicated. So if you just say small sediment versus medium versus large, and you don't put a number to that, then if someone else tried to do that, they might have a totally different idea of what small means or medium or large. So this sieve allows you to separate it out by size. So there's little grates here. This particular one looks like it's about 1 millimeter. I think there's oh yeah, the next one down is a bit bigger. So maybe like 0.5 centimeter. So basically whatever would stay on the top here is, we know it's bigger than 1 millimeter, right? So then in this case, you would just, so here's some mixed sediment. You just go like this and then shake it. There you go. So down there we have pieces that were less than 1 millimeter. And up here we have all the bigger pieces. And then you could just do that through successive sieves until you get all the right sizes. So we actually have a much finer sieve here as well. So we could use that for the sand down there if we wanted to get even smaller pieces. So in this way, you could say, so say your medium treatment might be pieces that were between 1 millimeter and 5 millimeters, and your small treatment might be less than 1 millimeter, and your big treatment might be, you know, between whatever, like greater than 1 millimeter, something like that. Okay. So this is a really good thing to consider if you're doing a sediment type test. Okay, are there any questions about all this so far? Right, so why don't I, what else am I gonna show you? I'll change the camera angle so I can show you some things from a different view. There, okay. All right. So a few other things we have here in terms of measurement. So you're going to make, so your first two choices that you're going to make are what kind of organism you're going to use, and you've already made that choice, it sounds like. And then what are you actually going to test? So some of the examples I provided are salinity, pH, sediment type, temperature, light, quality or quantity. So different wavelengths of light or different amounts of light. There's other things too. Let's see, what else? What am I missing? What else, Maria? Can you think of anything else?
You mean abiotic variables?
Yeah.
Let's see. What else is there? No, I can't think of any at the moment.
Yeah, there's probably
temperature, salinity, pH. Oh, dissolved oxygen was one. Can we do that?
It's a little harder to figure out how to vary that, but it is. We do have meters that can measure that, so there are ways to do it.
Okay.
Hardness is another one. We haven't really had anyone do that, but we could. So salt water is naturally pretty hard. So hardness is just how much of certain minerals are dissolved. So there are ways to vary it. So for example, in our coral tank here, the corals like really hard water because they need to take the calcium for their shells. So we have like powders we can use to make a harder water and a less hard water. So that's something you could do. We've had people also do substrate color. So like this. So they would put this underneath the dish and then see what the crab chose. And you could do the same thing for Tigriphis, just a much smaller one. Okay, so those are some of the examples. If you think of anything else, that's fine too. You can just pass it by me or Maria, and we'll let you know if it's feasible. That we're definitely open to new ideas as well. Okay, so those are the two. So the first two choices, like we said, organism, and then what you're actually going to measure. Then you need to figure out how you're going to measure the abiotic factor. So if we're doing pH, we want to actually be able to confirm that we have the pH we think we have. Same with salinity, temperature, etc. So we do have, for the pH, we have a pH meter. So as I said, if you're doing pH, most likely I'll just adjust the pH for you in advance, but then we'll get you to do a final reading of pH before the experiment just to confirm it's still at the pH that you think it is. Because things can vary a little, like we might prepare the solution, and then if it sits overnight, the actual pH may change a little. So it's always a good plan to measure it kind of right before you do the experiment, just to make sure you know what you're actually subjecting your little test subjects to.
Did you prepare the salinity in advance too, Robyn?
Yeah, I will.
Okay.
So for salinity, what I sometimes do, say you were doing 100, 30, and 0. I would prepare the 100 for you and get you to dilute it down yourself. So again, just depending on, I know we might be a little short on time, so I might just make it all for you, or I'd make it so it's pretty simple for you to dilute it down yourself. Okay?
That's good, yeah. Yeah. Excellent.
So for salinity, we have a refractometer that you can use. I think usually we use these on the field trip, but we haven't done the field trip yet, have we?
No, we haven't done the
Unless I'm
intertidal yet.
forgetting.
I
It was
think
so-
we're going to be doing it at midnight one night.
Ooh, perfect. That's the best time to do it. So then when we do that trip, hopefully you'll learn how to use these, but if not, you'll learn how to use them when you come in for this lab. So this is just a way of measuring how much salt is in the water. We also have light meters. We have a couple different types. So these will be able to allow you to measure how much light is coming through the filter. So again, this is also really useful because saying dark and medium, it doesn't mean much to someone else that's trying to do the experiment. So this way you can actually tell how much light is coming through and how much your organism is subjected to. And that way someone else could repeat it later if they wanted to. And then of course we have thermometers. So for temperature, we have water baths that we can keep at constant temperatures. So if you decide to do temperature, we can get like a water bath set to 35 or whatever your highest temperature is. And then room temperature, of course, is pretty straightforward because it is what it is. And then cold, we'll usually use a bit of ice in a dish, and you just put your dish on top of that. And then again, you just test it before. Yeah, so that's sort of the main measurement devices. So there could be other things too, depending on what you decide to do, and I'll let you know what we have if you have another idea. Okay. Other thing I wanted to show you, which I think is the last thing. Oh, sorry, I know what I was going to say. We've already talked about this, but the other thing you need to decide on is how to measure the organism response. So we've looked at one way of doing it, which is with the little string. That's a pretty good way to do it in terms of distance. People have also tried things like looking at vertical migration. That's a little harder because they can zigzag around. So usually we just try to do that so that if you're doing in a relatively flat dish, then you can be assured that it's not moving up and down too much, so that whatever distance you're measuring is just based on its vertical distance. And then the other one, of course, is the choice, so just seeing where it ends up. You could, if there's other things you find in the literature and you find a way to do it that doesn't seem too difficult, we can certainly look at other things as well. Okay, so I think then the final thing I'll show you is the different glassware, just so you know what to ask for. So I'm just going to switch to this other camera again. Okay.
What are you showing us now?
Glassware. Glass.
Ah.
I know it's not that exciting, but I just,
Glassware.
glassware. But did it sound like I said like classware or something?
Yeah, it sounds like something else. I thought you said flatware. I'm like,
Flatware.
what, are
Oh,
we doing ceramics now?
yeah, I decided to mix things up a little here. It's like, okay. I know this is pretty basic, but if you've done chemistry, you would have seen some of these things already. It's just important to kind of know for your design what kind of glassware you might need. So again, we have these different petri dishes. These are really good for the Tigriopus. I wouldn't use these for the crab because it's too thin for the crab and they'll jump out. So even if you have it covered, then the poor crab's kind of squished. So we don't want to do that. So if you're doing Tigriopus, I would recommend these small petri dishes as a test vessel if you're doing something where you're measuring distance. If you're doing more of a choice experiment, then you might want a large petri dish because then you can have your 3 choices on there and give it space to choose. There's also test tubes. So people have used these for vertical migration type studies. You also might want to use it to put your different solutions in, things like that. Erlenmeyer flask, this is a good vessel for mixing things in. And graduated cylinder, so this is what we use if we're doing different volumes. So if I were to give you your salt solution and you had to mix it up yourself, you would use this to measure how much salt solution to put in to dilute. Okay.
And every treatment should have the same volume of water.
Oh, yes, yes, exactly. Right. So this is another way that you would measure the volume. Yeah, you're right. Yeah. So yeah, you have to make sure you're putting the right amount into each dish. We have smaller ones as well. This one's a 25 mil, but we have 10 mil ones. It might be more like what you'll use. And then we have these little pasture pipettes. These are great for just getting the organisms, but you can also use them for measurements. So they have graduations on them. So if you need to do some volume measurements, you could use these too. And then this reagent bottle, this is usually what I will deliver your solutions to you in. So I'll have it in here, and that way we can store it, we can cap it up at the end, and then if you're doing another trial, I'm not sure if we're doing that or not this year, but if you are, then you can keep your solution all fresh and ready to go for the next time. Okay. And of course, stacking dishes. So these are great for using for the crabs because they have some side, they're tall, and that way the crab won't escape. So we have two main sizes. We have the large one, which is the one I showed you. Sorry, I've made a huge mess here now. Where is it? There's stuff everywhere. Okay, well, anyway, you saw the big one that we put the sand in. That's actually a really good one to use for crab for choice experiments. If you're doing more of just measuring the distance they travel, you might want to use a smaller stacking dish. Okay. And I think that's the main stuff. There's all sorts of other things we have too, depending on what you decide to do. But these are sort of the basic bits and pieces. Oh yeah, of course, beakers too. Beakers in different sizes. So. Okay, are there any questions about all that or anything else you want me to show you?
What's the largest dish we have for the crab? If the crabs are doing it, if you're doing a choice experiment with the crab, what would you recommend for that? There's a bucket right there. That looks like a
we
good
have
size.
this isn't bad. We have a bigger one too. And I can get something too if you like I can get a big garden saucer or something. We've sometimes used I'll just grab one. Just give me 1 sec, I'll go get some larger ones.
So does that give you a good idea of the equipment that we have available? All right, good.
Yeah, it does.
Okay. Yeah, the Tigriopus are they're quite small, but you can always use a dissecting scope. Or Robyn, do we have those large, what are they called? They look through them like they're a microscope, but
yeah, the circles, big lamp magazines.
Yeah.
Still have a few around. Yeah. Yeah.
That would be good for the Tigriopus, maybe.
Yeah. Yeah, for sure. You could use that. You can, I mean, once you get used to them, you can see them, but they are, yeah, they're pretty small. So it's a good idea to have that available. Yeah, so here's examples. So something like this size would be good. It's about a foot across. Yeah. So we have larger ones as well.
Is that a sandwich tray?
It's a disposable saucer for plants. It's like the plant.
Okay.
We have a better one. I just don't know where it is right now. We have a larger one with thicker sides and stuff, but this kind of size is a good size.
Oh, I think that's a sushi tray. I think you put having sushi.
Every day. Yeah, and so for choice experiments, I would say pretty much you always want to have it in a circle. That way you make sure the choices are even. If you have a square, it's hard to do 3 even choices without some complicated geometry. So as we're seeing here, right, this is a nice evenly spaced out set of choices. So that's a good way to do it for choice experiments.
Perfect. Terrific.
Yeah.
Thank you.
No problem. I'll send you, so as I said, I'll send you this list thing, and this helps you sort of think through what you need as well. So it just gives you prompts of the different categories of stuff you might need. And usually when people fill these out, they're usually missing a few things, which is okay. As long as I kind of understand what you're doing, I can usually think of other things you might need. Or of course, on the day you're doing the experiment, we'll be here to help you and grab things if you need them. But yeah, we'll send this to Maria so that you have it to fill out.
And you've got thermometers and ice.
Yep.
And the heating tub.
Yep.
Yeah, so we can change temperature as well if we need to. Okay, that's good to know. Awesome.
Okay, great. Any other questions for me before I zoom out of here? Or,
Thanks for joining us today. I really appreciate that. That's terrific.
no
It,
problem.
it,
Anytime.
it gives us a good connection with the lab and the college.
Yeah,
That's nice. Yeah,
no
but I
problem.
mean, biology is it's a lab-centric kind of subject. So
Yeah,
yeah, it's odd to be at home, but it's nice to
yeah,
be connected in some way and be able to
yeah,
go in sometimes and use it and
yes.
actually manipulate things. So yeah, thanks.
Yeah, no problem. I'll put my email address on this too in case you have questions about whether or not we have something. You can feel free to email me and I can let you know. Yeah. Okay.
Okay, thanks.
All right. Okay. Thanks, everyone.
All right,
Thank you.
see you, Robyn.
No problem. We'll see you soon.
Okay.